Good morning to everyone. So our today's lead code question is 1680, that is concatenation of consecutive binary numbers. So in this question we are given an integer n and we have to return the decimal value of all the binary strings formed by concatenating the binary representation of the numbers 1 to n in order, and its answer is very large, so we have to return the answer as modulo 10 to the power 9 by 7. So when n is equal to 1, uh, there is only one number, that is 1, so we'll be directly returning 1. Then when n is equal to 3, so what are the numbers we have? So we have 1, 2 and 3. Binary of 1 is 1 only, 2 is 1 0 and 3 is 1 1. So when we concatenate this, we will be getting the string 1 1 0 and 1 1. So now we have to return the decimal value of this. So the decimal value of this binary is 27, so our 27 is the answer. Similarly, next we have n is equal to 12. So we will be taking first all the number up to 12, and then we'll take their binary values, that is 1 1 0 1 1 and so on up to 12, and then we append all those numbers in a string. So this is the string, right? So and now what we have to do is we have to return the decimal value of this binary string, and if the answer is too long, we have to do 10 to the power 9 modulo 7, and then we have to return the answer. So if you'll see the constraints, the string length can be up to 10 to the power 5. So either we can think of some approach which will be in big of n or n log n, right? These two approaches will be working. So let's see our approach. So suppose if you are thinking of making string first, like if you'll what will do, you thinking of, suppose n is equal to 3, and you are thinking that you will make first append binary of 1, then append binary of 2, and then append binary of 3, like you will make the whole string. So basically it's a bad idea, and the question is like, wow, why? So what we are building is we are building the binary from 1 to n, right? And we have total n elements, and each element has the length up to log n. So what is the total length? N log n, right? And the average bit length can be up to 17. So total bits will be 1.7 million characters in the string. Though it is possible to make the string, but the actual problem is not in making the string. So actual problem is converting the string to the number. So that will be very slow, right? So what to do, like to make it faster? So what we can do is, like suppose we have, instead of making a string, we'll take some variable answer which will be 0 initially, right? And when we are at some number I, right? So what we do is we'll find all the bits of this I. Suppose I is 5, so it is 101, right? And suppose our answer is x at that time. Sorry. Suppose our answer is x at that time, right? So what we'll do is we multiply x by 2, then we'll add this first bit, right, plus this first bit, then again we do the same thing, right? For every bit we'll be doing the same thing. So this is a correct approach, but it is slower as we are processing for each and every bit of the number, right? So how to make it even more faster? So if we know the bit length, right, of the ith element, right, we have our answer, sorry, and the ith element. So if we know its bit length, like how many bits will it be having, if we know that, what we'll do is we will shift the answer by bit length. What does will that will do? Suppose now answer is 5 and our bit length is 3. So shifting 5. So what is the binary value of 5? 5 is no, not this. This is 3, 2, 4. Yeah, this is 5. So shifting by 3 bits, it will become 101,000. That means we are multiplying 5 by 2 3 times. This is equal to this because one right shift is equal to multiply by 2. So if we are shifting by 3 times, we are multiplying it by 3 times, right? And then what we'll do is we'll add I over here. So suppose if I have 111, then those will be added, so it will become 101,111. Now if you'll see here, earlier our answer was 5 and triple one is 7, so this is 7. So 5 into 2 into 2 into 2 plus 7 is what? 5 to the 10, 20, 40. It will be 47, right? So if you'll see the value of this also, 0, 1, 2, 3, 4, 5. 2 की power 5 plus 2 की power 3 plus 2 की power 2 plus 2 की power 1 plus 2 की power 0. So it is 32 plus 8 plus 4 plus 2 plus 1. 40, 44, 46, 47. So if you notice, both the numbers are equal only. Sorry. So let's see another example to explain it, understand it more clearly. So suppose our n is equal to 5. That means we have to take number from 1, 2, 3 and up to 5. And initially our answer is 0. So now we are at index 1, that is at number 1. So what is the binary of that number? 1. And what is the bit length? Bit length is also 1. And how, by how many bits we have to shift the answer? So whatever the bit length that we have, that we have to shift the answer. And then we have to add the number to that shifted answer. So we get 1 in binary and 1 in decimal. So next is like we move to 2. So the binary of 2 is 1 0. So it has bit length of 2, right? So if we'll shift our answer by 2 bits, it will become 100 in binary. Then what we do is we will be adding 2, that is 10 in this answer, right? So if we see from here 1, and then we are shifting by 2 bits, right? So 1 into 2 again into 2, and then adding our current number this, so it will become 6. See, it will become 6. Now now next we move to index number 3. It has bit length as 2, so again we'll be shifting our answer by 2 bits, that is 6 into 2 into 2 plus 3. So it will be 6 to the 12, 24 and 3 27. So by decimal we are getting our answer as 27. Let's see by binary approach. So earlier our answer was 110. So if we'll shift by 2 bits, it will become 110 and 00. Then we append this binary values here. So it will become 11011. So it is the binary representation of 27 only. So this way we'll be keep doing for all the n's. Now the thing is like, how will be finding the bit length? So if you have noticed, the bit length is changing at the power of 2, right? Bit length is changing at the power of 2. At 8 it will become 1000. So whenever we get a power of 2 to power of 2, we will increase bit length by 1, right? So let's see the code part of it. So sorry, we have made a variable to store the modulo answer, and initially our bit length is 1 because we will be starting from 1. And next is the means next is 2, that is next element where bit length will change. So first power of 2 is 2, right? So what we do is, suppose if I is equal to next, means we have reached at some power of 2, then that means our bit length will be increased by 1, right? Because suppose we will be earlier at 3, so 3 will be written as this, and then we move to 4. 4 is a power of 2. So our bit length here is 2, so we have to increase that by from 2 to 3. So we'll increase bit length by one value and increase our next element. So now earlier our next was 2 4, so what we'll make it, we'll make it 8, right? And then what we do is we'll shift our answer by bit length, and as you already know, this right shift means multiply by 2. So whatever answer we have, we will multiply that answer by 2. How many times? Bit length times, right? And then add our current number and do the modulo operation, and at the end we'll be returning our answer. So I hope I am able to explain you the whole approach properly. So if you like the solution, please make sure to like, share and subscribe the channel. Thank you.